Okay, so we know the fundamental of flip-flop, and I just told you, suppose I have to store a single bit data. In that case, flip-flop can solve the purpose. Okay, so flip-flop is nothing but this is one bit storage device. Uh, Other than these things, with the help of flip-flop, we designed the sequential circuit based on the requirement, based on the input-output combinations. We can design the sequential circuit. So this is what we have already done. As I told you, because as we know that the flip-flop is nothing but this is a single bit storage element. Okay, but what happens if we want to store more than one bit? Okay, so in that case, register comes into the picture, and that decides like if I have to store more than one bit. Okay, so I need to combine more number of flip-flops. Okay, so and if we are combining more number of flip-flops, so that makes a register. Okay, so what is the register? Register is a small data holding component that is a part of the processor. Okay, and let me tell you what exactly register is. If you have seen the processor, right, in the processor, like in any computer system, there could be two kind of memories. Okay, one memory could be like primary, and the second one is the secondary one. The second one is the other one is the secondary memory. Okay, what is the role of primary and secondary? Secondary memory is basically utilized to store the large data. Okay, if you have to store large data, then you have to use the secondary memory like hard disk and other things. So these all are the part of secondary memory, but you also need some primary memory, which will be fabricated inside the chip only or inside the processor only. Okay, so and these primary memory are nothing but these are the registers. Now the question is, what is the need of this register if we already have the secondary memory, okay, which can store the data? So let me tell you what happens. Suppose I have a processor. I'm giving some instruction to operate some of the operations. Let us, I have to add two numbers. Let us assume I want to add a plus b. I have to perform this operation. Then what I have to do? I have to face the I just told you ASCII code and other things can be used as a representation for any of the information like ABCD 1 2 3 something like that. So what I will get? I will get binary information that is equivalent to the a. Similarly, or ASCII code that is equivalent to a, ASCII code equivalent to b, and then ASCII code that is equivalent to the plus symbol. Like for all the symbols, we can also have some ASCII code. So what I will do, I will just press a key A. So at what it do? Once I press the key, that hex code, that ASCII code that went into the primary memory of the processor, and that primary memory is the register. So that store is one of the register. Now, when I'm pressing the plus symbol, then it will generate the ASCII code, and then that will be stored into the another register. And again, if I am writing B, then it will convert into the ASCII, and that will be stored into the register. So whatever the things I am just doing these things, like whatever the key I am pressing, those all are stored temporarily in the primary memory, which processor can execute. They can fetch, decode, and execute. So for these operations, the internal memories are required. Okay, what happens? Suppose if I am not using the internal memory for all these operations, and if you are fetching your information from the external memory or the secondary memory, so because the external memories are slow, so you need to fetch the data from external memory to the processor, then you will operate it, then you need to again store it. So that will create that, it will take long time. Okay, so for the faster performance, you must have some on-chip memories that can execute your operations with the faster space, and the speed will be faster. So for that purpose, you need some registers. Okay, for different microprocessor, the size of registers are different, and then how much data it can store, that will be different. Okay, so this kind of things we will discuss later on in more detail when I will talk about the microprocessor. Okay, so in the microprocessor we will see like what are the registers, how it perform the operation, and other things. All these things will be discussed. For now, what you have to understand, register is the storage element where we can store some of the data or small data that I can speed up the operation, whatever the operation I am doing, that will be faster. Okay, so this is all about the register. One more thing, what will be the size of register? I just told you, like a single flip-flop can store a single bit data. Okay, if a single flip-flop can store a single bit data, and suppose I have a processor which is of 8-bit, you must have heard like 8-bit processor, 16-bit processor, 32-bit processor. So what does it mean? It means that the size of the register will be this much, because the data which I am holding on the register will be of 8-bit or 16-bit or 32-bit or so on. Okay, so the size of register decide or that also depends on what is the what kind of processor we have. If it is the 8-bit processor, the register size will be 8-bit. Yes, one more thing that we can consider here. Suppose I want to use 8-bit register in 32-bit or in 16-bit registers, 16-bit processor. So this is also possible. Let me repeat again what I'm saying. Suppose I have a registers of 8-bit and I want to use those 8-bit register into the 16-bit processor. So this is also possible. In that case, I have to use the register pairs. Okay, so the two register pair can be utilized to hold the data. So this is also possible, and these things we will also discuss when I will explain you about the microprocessor. Okay, so each and everything will be discussed. So hope the points are clear, what exactly register is and how these registers are different from the secondary memories like the hard disk and other things. Okay, now so this is what we have. Now let us talk about some circuits. Okay, so I just told you what registers is. So let us take an example and try to understand how the register looks like. I just told you registers are nothing but they are just a group of flip-flops. Okay, one more thing that we have to consider here. What we need to consider, as of now we have studied 4 kind of flip-flops. The first flip-flop was the RS flip-flop, second one was the D flip-flop, third one was the JK flip-flop, and the fourth one was the T flip-flop. Okay, and if you try to relate all these flip-flops, the RS and flip-flop, D flip-flop, like D flip-flop is nothing but this is the extended version of the RS flip-flop. If we limit some of the combinations, then we will get the D flip-flop. Like in the D flip-flop, what we are using, R and S, these both inputs are complementary to each other. So I will get only 2 states. Out of 4, I will get only 2. Okay, so that we can remove these indeterminate states. Okay, so the D flip-flop is nothing but this is the extended version of the RS flip-flop. Now, if we talk about a JK flip-flop, because there was a problem in the RS flip-flop of indeterminate state, so to make it in the toggle kind of, we need to use the JK flip-flop. Okay, and then because for the counter designing, you need to toggle between 2 states, 0 and 1, or QT and QT bar, and for that purpose, we can connect both the J and K, and then I will get the T flip-flop. So this was the structure of all the flip-flops. Now the question is, why we are studying all these flip-flops? What is the importance of different kind of flip-flops, and what are the applications? So let us talk about those things as well. Okay, first let us start with the RS flip-flop. So I just told you RS flip-flop and the D flip-flops are in the same family. Okay, D flip-flop is the extended version of the RS flip-flop. So when you have to store a memory, store a data, in that case RS flip-flop and the D flip-flop is useful, because RS flip-flop and the D flip-flop has the capability to just pass the thing. Like if you can see the D flip-flop, whatever the input I am giving, if the clock is executed, it will pass the same logic to the output. Okay, and if clock is not executed, it will hold the data. Okay, it is not going to perform anything. So D flip-flop and the RS flip-flop can be utilized to hold the data, to hold so the RS and so see, all the flip-flops can hold the data. But if you want to store large number of data, in that case, D flip-flop can solve the purpose, because it is not performing any of the operations with the data, whatever we have given to the input. Okay, if the clock is executed, whatever the data has been given, that will be stored to the flip-flop, and during the next clock, it may be changed. Okay, so this is how it is holding the data. So if I have to store some data, if I have to make a register and other things, in that case, D flip-flop and the RS flip-flops may be used. Okay. Similarly, because the T flip-flop and the D flip-flop works on the a toggling state. I made a mistake. JK flip-flop and the T flip-flop are based on the toggling states. They have some toggling kind of thing. Instead of indeterminate state, they are giving some toggle states. Okay. So if they are giving some toggle state, what it means, they can be utilized to count the pulses, how many pulses we have received to the flip-flop. That can be done with the help of JK and the T flip-flop. Okay, so the clear-cut difference between these four sections, flip-flops are JK and the T flip-flop can be used for the counter designing, and the RS and the D flip-flop can be used for the register designing. Okay, so as of now, we'll discuss about the registers. Later on, we'll talk about the counters. Okay, so let us see how we can make the registers. To make the register, I just told you, I can use either RS flip-flop or the D flip-flop. Why will it is always recommended to consider D flip-flop? Because in the D flip, see, let me explain few things. Suppose I have a D flip-flop, okay, having only one input, and I will have a two output, Q bar and Q. Okay, this is the structure, and there may be some clock. Okay, so this may be out. If we talk about the RS flip-flop, I can have a two input, and there will be two output, Q and Q bar. Okay, and there may be one clock. What it do? If I know that in the RS flip-flop, we can have a four possibilities: 0, 0, 0, 1, 1, 0, and 1, 1. 0, 0, that can give you the past data. 0 and 1, like that can, like it is SR. Then 0 and 1, that will reset. 1, 0, that will set, and 1, 1 will give you the indeterminate data. But what is the role of register? The role of register is whatever data I have given, I have to just hold it, and in the next clock pulse, I have to pass it. This is the role of register. But if I will use RS flip-flop, then might be if the combination is 0, 0 or 1, 1, this can create the problem. It can create, like it can forward the same state what was the before if RS is equal to 0. Or if it is 1, 1, then it will create indeterminate state. It will not be decided what kind of logic I have to forward. So these two states are not required. And if these two states are not required, by default, I am getting only these two states, which are nothing but these are the D flip-flop, the states for the D flip-flop. Because see here, both the inputs are complementary in nature, and D flip-flop is nothing but if I connect R and S in the complementary form, I can get the D flip-flop. So that is why we always recommend D flip-flop to make the register to avoid these problems. Okay, hope points are clear. Okay, so what we have done here, we have used the D flip-flop here. So all the flip-flops, all the boxes, what we can see, these all are the D flip-flop. Now, these are the input, which are these are the clear that can be utilized to clear the things. Okay, so if I have to clear, then I can activate this signal. Okay, so if this logic is 0, it means whatever the data is stored, that will be cleared and the output will be received like 0, 0, 0, 0. Okay, and if it is 1, in that case, whatever the inputs are there, that will be passed through it. So the clearing, or if I want to clear the data, if I want to reset the data, in that case, I need to activate this one. Okay, I need to activate these things. Okay. So what we do during refreshing, suppose if you are refreshing any computer, and like in your computer, you just click the right click on the mouse, and then you have to refresh it. What you are doing, you are clearing the cache. If some of the registers, like see, whatever the registers I have, on those registers, if I have already performed the operations, but it has stored the data because we are not performing other operations. So it will temporarily store the data. So to refresh all those things, you need to clear it. Okay, so this is how it performs. This is how it clear the things. Okay, so this is the importance of this signal. Now, Let us try to see how it will hold the data. Suppose CP is there. CP is the clock pulse. Okay, if the clock pulse is like in the rising, because if you see here, this is nothing but the positive edge triggered. Okay, the positive edge triggered means if the clock is moving from low to high, then whatever the A0, A1, A2, A3 will be there, that will be passed to the Q0, Q1, Q2. So that will be hold at the Q, and that we can get the output. Okay, so this is the simple structure of the register. Okay, see, if I have connected more number of registers, 8 number of registers, then we can make it 8-bit register. As of now, because I have only 4 flip-flop that has been connected, what it means, whatever the diagram we are seeing here, this is nothing but this is the 4-bit register, and it can store the 4-bit data. Okay, the simple is, this is the simple working. Okay, just you have to understand this slide, and then later on you will be able to understand all the circuits whatever I'm going to project you. Okay, so see here, the basic thing is why we are using D flip-flop. I just told you how it is holding the data. I just told you because the D flip-flop is nothing but whatever the input I have given, that will be passed to the output in the next clock pulse. Okay, so whatever the input I will give here, okay, that will be stored here, and until unless it will store the same data until unless we are not changing this A0, A1 or A2 or A3. Okay, so that is why it will store the temporary data. It will temporarily store the data until we are not changing this one. Okay, and we know that what is the role of clear pulse. Clear pulse is to clear all the data. Suppose I have initially 0 1 0 1, I have just forwarded it, but some instead of time, if I want to clear it, I don't want any data in the register, so just I have to activate this signal, and then all the data will be 0. Okay, so this is the importance of register. Okay, so this is yeah, so if you can see here, there is no as such difference in this circuit. Just what I have done, we have made a common clear pulse and the common clock pulse, that's it. And the group of inputs, I am considering them as a group as an input, and how many data we can store, that is defined, and the output of all the flip-flop, that can be considered as an output of this register. So if you can combine all these things, this we can say 4-bit register it is. Okay, similarly, suppose if I want to perform it differently, as of now, what it will happen if the clock is activated and the clear is equal to 0, in that case, if I will get the A0, A1 and A2 data, whatever the data we have, that will immediately be transferred to the Q1, Q2, Q3, something like that. Okay, but if I want to either load the data, or if I don't want to load the data, then what will happen? Let us try to see here. This is the another way of representation of the same circuit. If load is equal to 0, okay, what is the problem with the first circuit? The problem with the first circuit is, like, suppose if the clock pulse is changing, and at the each instead of rising pulse, it will receive the data and it will change the output. Okay, A0, A1 will be transferred to the Q0, Q1, Q2, Q1 at each rising clock pulse. But what happens if I want to control it, like for some period of time? Suppose I want to pass the logic after 5th clock pulse. Okay, if I want to pass the logic after 4th clock pulse, so suppose I have passed at this instead of time, I don't want to pass at this instead of time, I don't want to pass at this instead of time, and now if I want to pass at this instead of time, then what I have to do? If I am using the above circuit, then this kind of operation is not possible. So in that case, the load signal play a major role. Okay, so the load signal play a major role means I have to activate a load signal. Let us assume the load is high at this point of time, and the load is 0, and the load is high again at this point of time. So whenever the load will be high, then it will consider the clock pulse, and in between that, even though there is a change in the clock pulse, it will not be considered because it is passing through the AND gate. So to make this AND gate logic 1, I need to make both the logic high. Okay, so this is how this AND gate play a major role in loading. So that decide at what instead of clock I have to perform the operation, in what instead of time I have to hold the data. Okay, so even though there is a transition in the clock, but because this load signal is not high, so this transition will not uh, affect the output of this register. Okay, so this is the importance of this signal, whatever we have. Rest all other things are same as before. Okay, so if anyone has any doubt at this point, you can ask the questions. One by one, we are going to increase the complexity, right? So that you should know the fundamental, that will help you to understand. Okay, anyone has any doubt at this point of time? And you should know what is the role of this register, this AND gate, right? So you can ask the question. Okay, fine. If there is no doubt, no response means no doubt. Okay, perfect. Yeah, before we move ahead, we need to consider some of the aspects in the register. And some of the registers are like register with the parallel load. Registers, there may be some possibility, like there may be some registers where we can have a serial input and the serial output shift register. What is the shift register? I will tell you. Okay, there could be serial input and the parallel output. There could be parallel input, parallel output, and the parallel input, serial output kind of combinations. Okay, so if we have this kind of like we can have this kind of registers. One more kind of register, we can have the bidirectional shift registers. Means this shift register can either, means by this name you can understand what is the meaning of shift register. Shift register means that can shift the data either in the left or in the right direction. Okay, so for each segment we will discuss about serial input, serial output, left shift register, serial input, serial output, right shift register, similarly for other combinations. And then we will also talk about how we can make a single circuit that can act as a bidirectional shift register. Based on our requirement, either we can shift in the left direction or in the right direction. So this is also possible, and that we'll understand. And then we'll talk about how we can use it as a universal register. Like universal register means what? I can use the same circuit as a serial input, serial output. I can use the same register as a serial input, parallel output, and so on. Okay, so for all kind of arrangement we can make in the universal kind of register, and we'll try to see how we can make the universal register. So as we will keep on moving in the bottom side in this direction, the complexity is going to be increased. Okay, the complexity depends on what is the at which state we are considering. Okay, so let us discuss first one, which is the register with the parallel load. Parallel load means what? As of now, what we saw in the previous slide, the load decides at which point I have to consider the input or the clock. Like even though the clock is activated, but at which point I have to consider the change in the input, that is decided by the load signal. Okay, and that AND gate was there. Now let us talk about if I have a register with the parallel load, then how it looks like. Okay, yeah, so the same circuit what we studied before. Whatever the clock pulse we have here, this clock pulse are nothing but these all are the decided by parallelly, and that is controlled with the load. Okay, and all the clock pulse are parallelly controlled by this load signal. So the same circuit which we have studied before, that we can call it the register with the parallel load. Okay, parallel load means what? Because all the clock pulse I have here, this clock pulse, suppose if there is no this AND gate, so if it is 1, then this clock pulse will be activated, and whatever the inputs we have, that will be transferred. Okay, but now what we are doing through this load signal, we are controlling the clock of all the flip-flop, and parallelly we are controlling it. So that is why we can call it the register with the parallel load. Okay, and this is the module. And if you try to see the working of this one, like the truth table, so let us try to see how it will happen, how it will work. If the let us assume if the clock pulse, like this clock pulse will transfer only if this load is equal to 1. If load is equal to 0, let us assume this one, if load is equal to 0, in that case whatever the input I am giving, it does not matter, I will get always whatever the input we have, that will always hold the previous state means the no change in the output. Okay. Now let us talk about the other cases. Even though if it is 0, like 0 or 1, but if clear input is 1, clear input is equal to 0. If clear is equal to 0, what it means? Whatever the operations I will perform here on the load or the CP, it does not matter. Okay. Why? And the output will always be the in the clear state. So clear signal, if the clear signal is activated, what it means, even though there is some change in the inputs, it does not matter. Output will always be 0 only. Okay, so the output will always be 0 if the clear is 0. Similarly, now let us talk about if the load is 1, means we can load this, we have given load is 1, and now clear is 1. Clear is 1 means the data will not be clear because it is the active low. Okay, clear is 1. Now I have to check the clock pulse state, because if you see here, this clock pulse is nothing but this is the positive level trigger. This is the positive level trigger. Okay, and if it is positive level trigger means what? If the clock pulse is low, whatever the input I will receive, it does not matter, it will hold the previous data. Okay, and if we see the last state, if load is equal to 1, clear is equal to 1, and the clock pulse is equal to high, so we are meeting all the conditions to change this data in the flip-flop. Okay, so in that case, whatever the input I will get, that will be reflected to the output, and that will be loaded into this register. Okay, so this is how this register works. So you should understand, like see, whatever the register we will see later on, all the register will work like this only. Okay, so they are not that much tough, they are very easy to understand. They are nothing but they have just all the flip-flops are getting connected, and based on the control signal we can tell the name, like what is the name of that register, that's it. Okay, so this is how this register with the parallel load works. Now yeah,
can you tell again how it acts as a parallel load? I couldn't understand that.
okay, so if we are talking about the parallel load, let us try to see here. I just told you, whatever the if the clock pulse is equal to 1, because see, all the flip-flops are the positive level trigger. Okay, positive level trigger means what? The clock pulse should be high to activate these flip-flops. So let us assume the clock pulse is equal to 1. Okay, and the loads clear pulse is equal to 0. So clear pulse is equal to 1. Okay, if clear pulse is equal to 1 means the data will not be clear. And now if I am providing load is equal to 1, so what will happen? The output of this AND gate will be logic 1. Okay, if this is 1 means all the clock pulse will be activated, all the clock pulse for all the flip-flop will be activated at the same time parallelly. So whatever the data I have here, that will be loaded at the same time when the clock was activated, and all the loadings are performed at the same time or simultaneously to all the flip-flops parallelly, so we can call them the parallel loading. You got the answer?
Yes, sir. Yes, sir.